So just a recap real quick. A couple things that you need to know about Normalcdf. I feel like most of you need to tell yourselves how to access it. Second vars is what you press to either access Normalcdf or Invnorm. Normalcdf, what does it do? It calculates a probability under the curve between two values. But this one you have to be careful. Sometimes the question gives you two values, an upper and a lower limit. Sometimes it doesn't. It will tell you, for example, here, how percentage making between these two values. You know it's start and stop, right? You just put them in here. However, what if it just says more than or at least? Like it just kind of leaves it open-ended. You just need to, we have a trick for that. So if it says at least 75,000, it kind of tells us more than 75,000. So 75 is our low limit, and you just pick a really large number to put in here. As many zeros as possible if you're not sure. And followed by mean and standard deviation, and then we find a percentage. So can I just say something? Normalcdf finds you the percentage. It will never tell you the number of items. That is something that would be an extra additional step where I would have to tell you, right, how many people are being surveyed, and then you multiply this by the number of people, right, to figure out the exact number. That would be a 2-mark question. And then there's the at most issue where you have an upper limit, and so this is the at most. At most means here and everything below that mark. Okay, so you got to make sure you understand that. So you technically don't have a start. You don't have a quote-unquote start. Just pick a really small number. Like this negative a million is over here. I probably would have to go out the building. Just keep going. Not funny? No. Okay. That's negative a million though in this case. And so you want to, did I tell you that this curve technically never touches the x-axis? And the reason being is that there's a chance, there's always a chance that there's a point like way out there called an outlier. So that's why this curve technically never touches the x-axis. If you were to zoom in, it would just go on. You would just keep zooming in, zooming in, zooming in. It would never touch, even though it looks like it, okay? So that's Normalcdf. Inverse norm, however, let's go to page 33. Inverse norm only needs 3 entries. 3 entries. And here you have to think of Beyonce's song, right? Is it Beyonce? Yeah, to the left, yes it is. 3 entries, so both of these need the mean and the standard deviation at the end. But inverse norm wants the percentage of data points that would be below that point or to the left of that point on the curve. So why is that important? This is why. The question may give you what is above it. They may say 35% of people earn more than 50,000 a year. It's important, but we need to understand that it's here. Therefore, we need to figure out, knowing that it's 100% under the curve, we know that this is 65, and that's what inverse norm would want for you to enter. That's how it does it, okay? And usually we will be finding this. This is going to be our unknown, okay? It wants you to figure out that certain value that would have this breakdown of, in this case, 4258. Or in this case 3070, right? What is that number along the x-axis that would slice this curve up so that there's 70 above, 30 below? Okay, that's what inverse norm does. You're slicing it up and you're touching the x-axis, and that's what you want to find, okay? So let's do a couple more examples. This is the one I wanted. I need to really get your attention on this one. There will probably be at least one on the test where I ask, like, what percentage is below a certain value or above a certain value. It means that you have to add up these tails or you use the indirect reasoning where you know it's 100% under the entire curve, and you actually use normal CDF to find the good pieces in this case, and you just subtract the good from 1 to give you that both tails combined already. So you either add up the tails or you find the middle and subtract it from 1. 2 methods to do that, okay? Yeah.
So when you're using Invnorm and Normalcdf, do you need to make that a graph?
You don't need to. Highly recommend. Yeah, you don't need to, but highly recommend. So let's do a few more inverse norm scenarios, okay? Let's go to page 35. I will also do 36. So after this, hopefully you know what you're doing. I'm just going to copy the mean and the standard deviation from the previous page. We've got 250 and 5. And remember, put units everywhere. We're talking potato chips. So this is just continued. If a company produces 5,400 bags per day, how many bags would be removed from the production line? This is based on the previous answer, right? 2.21% of bags. But that's not the question. It's actually asking for the number of bags. So you've already done the work. So now you just need to go number of bags. We just go 0.0. Sorry, is it this? Yeah, 2.21. Sorry, I just had to make sure. 0.0221 times 5,400. That gives you 119.34. You can't have that. So you say approximately 119, or you can say approximately 120 bags would be removed. Probably if you're working for the company, you would go on the conservative side and say we're removing 120 bags, right? It would probably make a bit more sense, because even if it's less, then you're still fine.
Why do you round 119 to 120 though?
Yeah, I know you were told, right? Look at the decimal right beside it, and it's a round up or down. So if you round down, that's fine. But often the province will accept both, because in a production situation, you probably want to be safe and say 120, right? You're like, how many are we going to remove from the assembly line? It's better to say 120 and then be off by 1 on the low end than to say the other way, right? Okay. If you want to calculate your losses, right? But either one would be acceptable. Okay. What percent of bags, right, have a weight with a z-score between -0.6 and 1.34? This is where I need to draw your attention. We didn't do this before. If you are thinking z-score, what is your new mean and your new standard deviation? Yes, I'm reading lips. Okay. Thank you. 0 and 1. Got it? And if it says percentage of bags, are we going to use normal CDF or inverse norm? Normal CDF. Right? So normal CDF, you're going to go -0.6, 1.34, 0, 1. And I'll tell you a secret. Maybe I shouldn't. Maybe I should. Anyways, if you just do this with normal CDF, you close the bracket and just hit enter, it's going to assume the mean is 0 and the standard deviation is 1. It's just going to assume that's default. So if you want to omit this, you can. I would strongly suggest against it, because then you'll forget to do this part with the other questions where the mean is not 0 and the standard deviation is not 1. But you may do that, okay? So let's go times 100, you get, let me just line up my key. Why is my key not lining up? I hope it did when you were 63.56. This is the answer. Now, is it possible to calculate the actual weight of a z-score with negative 0.6? Yes, it is, right? Calculate the actual weights that correspond to each z-score above. What percentage of bags between these, or would the percentage of bags between these be the same? And I'm arguing yes. Can you just do this here for a sec? This is 0, right? A z-score with negative 0.6 would put you right about there. Negative 0.6. A z-score of 1.34 is going to be a little bit further away above the mean, right? 1.34. Each of these z-scores, let's put z here. Each of these z-scores has an actual value. Let's put weight down there. There's a weight that corresponds to this number, and there's a weight that corresponds to that number. We know that the value is z times standard deviation plus this. Okay? So, the actual value for negative 0.6 standard deviation is, you got to use not, the 5 here plus the 250. This amounts to, you can use your calculator, just type this in as is. This is going to be 247 grams. You do the same thing again. But this time the z-score is 1.34. It's this one. Times 5 plus 250. You're going to get 256.7 grams. And I used way too much space. But watch this. Normalcdf 247 to 256.7. Now that you're using the actual weight, you have to use the actual average, 250 and 5, okay, times 100. You think you're going to get the same answer as this? Yes, you will. I'm going to use a red pen. The 247 is here, and the 256.7 is right there. Okay, you've basically found the actual weight that correspond to each one of these z-scores. So I'm just going to show you. Second verse, 247, 256.7, 250, and 5. Right? You multiply that by 100, it's 63.56, just like we had before. 63.56%. I will highlight both of those answers, like this one here and this one here. They are the same. So if you use these scores or if you use the actual scores, you get the same answer. Next question. The company would like to know the weight, like the weight, the actual value along the x-axis that would place 65% of the bags produced below this weight. Okay? What would you do here? I would strongly suggest do a little bell curve. And you got to slice this up. Where is that slice going to go? 65 of the bags will be below this weight. Would it be higher up that slice or would it be lower? If 65%, you should probably know this is your 50-50 line, right? If 65% are below, then this is probably where you're at. Okay? And so that puts 65% to the left already, which means this is 35. You subtract it from 100. And I'm going to stick to yesterday's highlighter, orange. So this question already gave you what you needed in the first place. This is the value you're interested in. So we go inverse norm. 0.65. You have to turn it into a decimal, by the way. There's no if you do 65, it's not going to work for you. And then you go 250 and 5. Okay. I'm going to highlight this 0.65 here. And if you do that, right, second vars, inverse norm, 0.65, 250, 5. It's 251.93 is the grams, okay? In this case, it's grams. It's the actual value, right? You found where, like that x value that's along the x-axis, right? Okay. The company would like to know what weight would 6% of the bags produce. At what weight would 6% of the bags produce? This is a typo. Would 6% of the bags produced be heavier than it? I know it's worded very weirdly, right? But they give you a percentage. 6% would be heavier than that bag that you're looking for. I think we would all agree that this is where you would slice it. This is the question mark, and that they give you 6%. Okay, 6% is right there. Is heavier. It's the percentage above the question mark. So that's where I would slice it. Which means that this is 94%, right? And that is the one inverse norm needs. So this would be a 2-mark question if you have to do this extra step of subtracting. Maybe I haven't shown this enough, but I'm just going to say this is 100 minus 6. That's how I got that. Okay. So inverse norm. This is 0.94. This would be 250, 5. No need to multiply or anything like that. This would be 257.77 grams. I'm going to stop after this. Determine the z-score of a bag that's heavier than 55% of the bags produced. Let's do your little bell curve. a bag would be heavier than 55% of the bags produced. This is your 50. If you find this weight would be heavier than 50% of the bags produced. So 55 is like right here. Okay, that's the one, that's where we want it. And so they actually, if you read this carefully, they give you the 55% where it's supposed to be. Okay, right there. So this is inverse norm, 0.55. You can do this the hard way, or you can do this a little bit easier. If you want the z-score, what is the mean and the standard deviation that you should be putting in here? 0 and 1. Hey, you are paying attention, good. It's not just me talking to myself. I'm too excited about stats. I know it's very dry and boring, but hopefully some of you will appreciate it. Yes, because it's a z-score, right? This is filled in for us. Like, we know that that's what we're going to put in there. If you put in 250 and 5, you're not going to find a z-score. You're going to find the actual weight. Okay? So you have to be careful. What is this again? This would be 0.13 is the z-score. 0.13. What does that tell us? It's positive, right? Which means if it's a positive z-score, you're a little bit higher than the average, because 0 is right down the average. Positive means you're above the average, but not by much. And that explains why it's only 55% of bags being, right, less than this weight. So it kind of does jive. Try to check for that. I want to say something about this. Mr. Erickson's z-score, if you want the z-score, you gave us this formula. Where is that formula for z-score? I'm going to go back a little bit. Remember that formula? This is on page 25. Why didn't I use this formula? Because I didn't know what the actual value was that we're talking about. I do know my mean and the standard deviation, but I don't know the actual value. That's hint number 1. That's why I didn't use it. Second reason I didn't use it is because this question gives me a percentage. When you're given a percentage, chances are you're going to use inverse norm anyways. Okay? So I'll just say note, percentage given, use inverse norm, not z-score formula, okay? Oops, you can't see that. Okay, this is just a note for you, because sometimes students are like, wait a minute, you gave us a formula, why didn't you use the formula here? You didn't have enough information to do that. It didn't give you a value, but I did give you a percentage. Okay? Now that you have the z-score, you could technically use the formula to figure out the actual weight that would go with it. Or you could just go 250 here and 5, you would also get the actual weight. Okay. I'm going to stop here. We're going to continue.